Okay, what I'm going to try to do is run through very quickly the lab number 3 for Physical Science 103 Collision Lab. So what you need to do is get your copy of the Collision Lab document out so that I don't have to share that document. What I'm going to share is the simulation itself. So there are a number of things, questions in here that I'm not going to cover. I'm just going to show you how the simulation information fits into the 2 tables that are in this document. The first simulation is going to be totally elastic. Right? You need to read, you need to look up and find out what that means. What does an elastic, 100% elastic collision means something? And that answers question number 4. Okay, so let me share the collision lab. Here we go. All right. So you notice several options here. We're going to start with the introductory. Okay, and that's what you see when it first comes up. And you can get a lot of the starting conditions can be gotten from the color plate that's here on this page. What you want to do is first click on this more data. There you go. Now you can see the conditions that you can set yourself. And then it may be helpful also to click on this one that says values. All right, that gives you a little more information. Be sure that this slider is set far to the right, 100% elastic. Okay. So there are 4 experiments in this table, and we're going to set up the first one. So if you click on the mass 1 is to the left, mass 2 is to the right. And in your table, M1 is mass 1. So M1 is supposed to be, I just clicked on that. Let me do that again. I just clicked on this box and an input panel came up. And you set it for a 1, enter. That's 1 kilogram. 2 is also 1 kilogram. So you go do the same thing for that one there. The position doesn't matter. As long as these 2 masses are separated, then when you start the simulation, they will have space between them that they cover that ground to collide. So the position doesn't matter. You just accept the default. And if you put in some things and you don't think they're right, then you can reset it, go back to the beginning, just click this little arrow that's chasing its own tail, and you can start all over again. The velocities, according to this first experiment, the velocity for 1 is going to be 1.5. So 1.5, enter. There you go. And then the velocity for number 2 is 0. So you just click 0 and enter. Okay. Now the total, the P total, which is the momentum, the total momentum is the summation of these 2 values right here. 1.50 plus 0 is 1.50. So in the before collision in experiment 1, 1.50 is the total momentum. Now you should be expecting whether the collision is elastic or inelastic, doesn't matter. Conservation of momentum is required. So in the after collision, the P total for after collision should be exactly the same. Let's see if it is. Another thing that you may want to do is click the slow button instead of normal. That slows it down so that you can click on this go button and then you can pause it shortly after the collision. So watch carefully. Click. Click again. Okay. Now we've got our after collision information. Okay. The velocity after collision, you look down here to the velocity. The velocity of 1 is 0. That goes in V1 after collision. 1.50 goes in V2 after collision. And then the total you notice over here, even though they're reversed, now this one is 0 and that one is 1.5. Add them together, 1.5. So that's what we expect. Now let's reset it and do the second experiment. 1.25 for the first mass, 1.25. And the second mass is 2.50. So the second mass is big. There we go. The velocity for 1 is 0. So you click that and give it 1. So now mass 1 is stationary. And the velocity of 2 is a -1. So it's going to go to the left. By convention, to the right is positive, to the left is negative. So we're going to have a velocity of 1 and just change the sign and enter. Okay. Now you'll notice that the total momentum here is minus 2.50. That goes in before collision for the second experiment, total momentum. Now we're going to start the sim and get ready to stop it when the collision occurs. Okay. Now you got values up here, but you also have them in the table. The velocity of 1 after the collision is minus 1.33. So that goes in the velocity of 1 after collision, and then the velocity of 2 after collision is minus 0.33. Then you go over here and look. Momentum of 1 is minus 1.67. The momentum of 2 is minus 0.83. Add them together, and you get minus 2.5, which should be the same as the momentum before the collision. Okay. You can do the third experiment yourself. The fourth experiment may give you some trouble. So let's reset. And you're given the mass for 1. So let's go ahead and set the mass for 1. The mass for 1 is 3 kilograms. Okay. You're also given the velocity for 1 is 3 meters per second. And the velocity for 2 is minus 1. So we'll leave that one alone. Now, you want the total momentum before collision to be 8. Right? You can't change it here. What you have to do is change the value for M2. That's in your table. It's a variable in your table. Change it until you get the total momentum to equal 8. So it's at 250 now. Let's change it to 2 and see what happens. All right, 9 minus 2 is 7. That's not big enough. So let's go maybe to 1. 1 kilogram. 9 minus 1 is 8. Now you have 8 kilogram meters per second is the momentum. And those are the values that you put in your table. Okay, now we can run the sim and see what happens to it. Okay, I'm going to stop it. Okay, now we can look at the values. All right, so what's the velocity for a mass 1 now? Mass 1 is 1 meter per second. Put that in your table. Velocity for 2 is 5 meters per second. And then you look at the total, 3 plus 5 is 8. So you put 8 in the total for after collision. And as it turns out, 8 after collision equals 8 before collision. That's the first table. And which is totally elastic collisions. Now, for the a bunch of questions after that you can answer. Now, for the second one, the inelastic collision, it tells us to go to the stay in the introduction, right? We're still in the introduction. Let's reset it. Okay. And now we want a totally inelastic collision, which means in this bar right here that says elasticity, you can either click there, and it won't let you. Okay, so take the slider and go all the way to the left. That's 0% elasticity, which means totally inelastic collision. Okay, that's where we're set. And again, the position doesn't matter. Leave everything else the way it is. You can click constant size if you want to, but sometimes it's useful to see a difference in size when you change the mass. So let's flip over to the table in number 10, I think it is. Yeah, 10, but it's on page 5. Okay, for this one, you do the same thing. You set the masses, right? For the first experiment, this one's 2. For the second experiment, also 2. Okay. The velocity for 1 is 150. So we change 150, 1.5, and then 0. So the second mass is stationary. Okay. Notice that the total momentum here is 3. 3 plus 0 is 3. Now let's run the sim. It's still set on slow. That's good. And see what happens. Notice for a 0% elasticity or totally inelastic collision, when they collide, they stick together and they travel as one unit. Okay. What does that mean to our table? Well, before the collision, we had 3 kilogram meters per second. What is it after the collision? 150 plus 150 is total momentum, 3. Okay, what's the velocity? The velocity is the same for both of them because they're now stuck together. Right? So in the table, there's only a place for combined velocity, because with a 0% elastic collision or totally inelastic collision, when the 2 masses connect, they move as one. So you don't have to add anything together. The combined velocity is the velocity for 1. It's the same as the velocity for 2. So in that part of the table, it's 0.75 meters per second. Okay, I'm going to let you do experiment 2 and 3 on your own. We'll look at the last one. This is another one of those solve the unknown situations like the first table. So let's reset and set our masses at 3 for the first mass. We'll have to work on the system to determine what the mass for 2 is. So let's go put in the other information that's given to us. The velocity of 1 is 3. And the velocity of 2 is -1. So click 1, change the sign. There we go. Now, what is the total momentum? It's supposed to be 8, but 9 minus 2 is 7. That's wrong. So let's go over here and change this maybe to a 1 and see what happens. There it is. 9 minus 1 is 8. So we know what to put in the mass 2 column, 1 kilogram. Okay. And the momentum before the collision is 8. Now we can run the simulation and collect our data. Okay, there it goes. Stop it. Notice they stuck together again, just like before, just like all the previous experiments for this 0% elastic collision. Now let's see what the combined momentum is. 6 plus 2 is 8. What's the combined velocity? It's 2 meters per second because they're both moving together at the same velocity. 2 meters per second, 2 meters per second. That is the combined velocity. Okay? So with that information, you should be able to fill in both of those tables. Then it's up to you to answer the questions.